Hello and welcome to Swecodes. In this video we will look into the explanation of the Leetcode problem 726, number of atoms. We'll dive deep into this challenging problem and explore an efficient solution. Let's start with the problem statement. We're given a chemical formula as a string, and our task is to return the count of each atom. There are a few important rules to keep in mind. Number 1. Atomic elements always start with an uppercase letter, followed by lowercase letters. Number 2. The element count follows the element if it's greater than 1. Number 3. Formulas can be concatenated. Number 4. Parentheses can group formulas, and may have an optional count. To better understand the problem, let's look at a few examples. First, we have H2O. Here, we simply count 2 hydrogen atoms and 1 oxygen atom. Next, let's consider MgOH2. We have 1 magnesium atom, and the OH group is repeated twice, giving us 2 oxygen atoms and 2 hydrogen atoms. Our most complex example is K4ONSO322. We start with 4 potassium atoms. The outer parentheses group is repeated twice, so we double everything inside. This gives us 2 nitrogen atoms, 14 oxygen atoms, 2 from ON, and 12 from the SO3 groups, and 4 sulfur atoms. Before diving into the solution, let's consider some initial thoughts on how to approach this problem. 1. We'll need a stack to handle nested parentheses. 2. We should parse the formula from left to right. 3. We need to keep track of atom counts at each level. 4. When closing parentheses, we'll multiply the counts. 5. A dictionary or map will be useful for storing the final counts. Now, let's outline our optimal solution. 1. We'll use a stack of dictionaries to handle nested structures. 2. We'll parse the formula character by character. 3. We'll handle uppercase letters as new atoms, and lowercase letters as continuations of atom names. 4. We'll process digits for atom counts and handle parentheses. 5. When closing parentheses, we'll merge dictionaries and multiply counts. 6. Finally, we'll sort the final dictionary and format the output string. Let's walk through the Java code that implements this solution. We start by initializing a stack of TreeMaps to handle our nested structures. As we iterate through the formula, we handle 3 main cases. 1. Opening parenthesis, we push a new tree map onto our stack. 2. Closing parenthesis, we pop the top map, apply any multiplicity, and merge it with the map below. 3. Atoms, we parse the atom name and count, updating our current top map. After processing the entire formula, we build our final output string, including counts greater than 1. Let's analyze the time and space complexity of our solution. The time complexity is O(n), where n is the length of the formula. We parse each character once, and our HashMap operations are O(1) on average. The space complexity is also O(n). In the worst case, our stack could be as large as the input, and our output string will be proportional to the input size. And there you have it. We've solved the number of atoms problem efficiently. I hope this explanation has been helpful. Happy coding, and thanks for watching.